Welcome to solverfy.
So in this problem, we have a reaction of a solution of sulfuric acid with lead acetate, which will produce solid lead sulfate and a solution of acetic acid. So if we write down the reaction will be like this, where we have um, the sulfuric acid reacting with lead acetate to produce lead sulfate and uh, lead um, lead sulfate and acetic acid. So before solving the problem, we have to balance this equation. So we will start with our metal here, which is lead. We have one lead on each side. Then we have one sulfate on each side. Then we have two acetate in reactant side, but we have only one acetate in the product side. For that reason, we will put a 2 here. Now we have two acetate on both sides, and we have two hydrogen on both sides. That means this is our balanced reaction equation. Now we are given 5 gram of each reactant to react, and we have to find out how many grams of which all the reactants and products will remain in the reaction mixture after a complete reaction. So to calculate that, what we have to do first is we have to find out the number of moles for 5 gram of each reactant. So 5 gram sulfuric acid in number of moles will be 5 gram over the molar mass of sulfuric acid, which is 98.08 gram per mole, and it will give us a value of 0.051 mole H2SO4. So this is our number of moles for 5 gram H2SO4, and 5 gram lead acetate in number of moles will be 5 gram over molar mass of lead acetate, which is 325.29 gram per mole, and it will give us value of 0.015 mole lead acetate. Now, since from the balanced equation we can see that 1 mole of sulfuric acid will react with 1 mole of lead acetate, that means 0.015 mole of lead acetate will react with 0.015 mole of sulfuric acid. That means since this reactant will be completely consumed, since it is um, lower in amount, that means this is our limiting reactant. And if we just write down the initial and final amount of each reactant and product, from there we'll be able to write down how many grams of which reactant and product will remain in the final mixture. So the initial amount of H2SO4 is 0.051 mole. So we are writing the mole here since all the amounts will be in mole. So the amount of sulfuric acid is 0.051 mole, the initial amount, and for lead acetate the initial amount is 0.015 mole, and initially we don't have any lead sulfate or acetic acid. Then we'll find out the change. So the change will be, since 0.015 mole of acetic acid will react with 0.015 mole of sulfuric acid, that means the change will be minus 0.015 mole for sulfuric acid and minus 0.015 mole for lead acetate, and it will produce, since 1 mole of sulfuric acid and 1 mole of lead acetate produce 1 mole of lead sulfate. That means 0.015 mole of lead acid will produce 0.015 mole of lead sulfate. And since 1 mole of the reactants produce 2 mole of the product, that means the product um, of the acetic acid will be 2 times 0.015 mole, or 0.031 mole will be produced for acetic acid. So in the final mixture, we will have 0.051 minus 0.015 mole of uh, H2SO4, which will give us 0.036 mole of H2SO4. And since the limiting reactant will react completely, that means is 0.015 minus 0.015 means 0 mole of lead acetate will remain. Then we will have 0.015 mole of lead sulfate and 0.031 mole of the acetic acid. Now what we will do is we will simply find the mass of each number of mole here, and that will give us the final amounts in grams for each reactant and product. So mass of H2SO4 will be the number of moles of H2SO4 remaining, which is 0.036 mole, times the molar mass of sulfuric acid, which is 98.08 gram per mole, and will give us a value of 3.53 gram H2SO4. Then since all the lead acetate is reacted or completely consumed, that means the mass of lead acetate will be 0. Will be 0. Then mass of lead sulfate will be the number of moles of lead sulfate produced, which is 0.015 mole, times the molar mass of lead sulfate, which is 303.26 gram per mole. It will give us a value of 4.55 gram lead sulfate. And finally, the mass of acetic acid will be the number of moles of acetic acid produced, which is 0.031 mole, times the molar mass of acetic acid, which is 60.052 gram per mole, and this will give us a value of 1.86 gram acetic acid. So after the reaction is complete in the mixture, we will have 4.55 gram lead sulfate, 1.86 gram acetic acid, 3.53 gram sulfuric acid, and we will have no amount of lead acetate remaining.